All right, so lesson 8.9, perfect square trinomials. So if you remember from lesson 8.4, we talked about special cases. Here's one of them. When I take the square of a binomial sum, my final answer is going to be a squared plus 2ab plus b squared. And I remember saying, hey, you should remember that. That's going to be really important. So today we're going to factor these. We're going to factor perfect square trinomials. Some of them will have a sum joining them. Some of them will look like this, a squared minus 2ab plus b squared, which lets me know that the binomial was actually a subtraction, joined by subtraction. Okay, so let's take a look at this first example, x squared plus 10x plus 25. Now, hopefully you can recognize that this follows the perfect square trinomial pattern. However, if you don't, a hint would be to take the square root of the first term and the square root of the last term. If the first term is a perfect square, the square root of x squared is, of course, x. If the last term is a perfect square, the square root of 25 is 5. And because both of these are addition, I'm going to join this with addition. So this is the same thing as saying x plus 5 times the quantity x plus 5, which we write as x plus 5, the quantity squared. Okay, perfect square trinomials. Let's look at another example. Now remember, let's look at this one. I have 4x squared. Perfect square. Let's see if we can take the square root of it. The square root of 4 is 2. The square root of x squared is x. The square root of 16 is 4. How can I check that? Well, remember that the pattern is a squared plus 2ab plus b squared. So once you find the square root of these two terms, the 2x and the 4, 2x times 4 is 8x. 2x times 4 is 8x. Following the pattern, take 2 times the product of a and b, or 2 times 8x, and you get 16x. So see how that follows this pattern right here? So our answer, 2x plus 4, the quantity squared. Let's look at one last example before we get into our notes. So 9x squared minus 6x plus 1. 9x is a perfect square. The square root of 9 is 3. The square root of x squared is x. 1 is also a perfect square. We forget about that one sometimes. The square root of 1 is 1. So let's see, does it follow the pattern? What is a times b, or 3 times negative 1 is negative 3. Times 2 is negative 6. It does indeed follow the a squared minus 2ab plus b squared pattern. So this is actually a perfect square trinomial, which means my final answer is this. So this is a way to check. Hopefully you are going to be able to recognize them spot on. So let's look at our first example. This is in your notes. So using what we talked about, is 9 a perfect square? It is. The square root of 9 is actually 3. The square root of g squared is g. I'm taking the square root of both of these. What about the square root of 4? Well, the square root of 4 is 2. 3 times 2 is 6. So I have 6g. Times 2 equals 12. So this follows the perfect square trinomial pattern. So the factors of 9g squared plus 12g plus 4 are 3g plus 2 times the quantity 3g plus 2, which simplified is going to be written as 3g plus 2, the quantity squared. This is the way that I want you to write them. This can be simplified into this. This will give you -1 on a test. Okay? Let's look at another example. 9g squared minus 12g plus 4, very similar to the one that we just looked at. We can take the square root of 9, which is 3, the square root of g squared, which is g, Let's look at the square root of 4. That's 2. Notice that this is a subtraction sign, so these are going to be joined by a subtraction sign if I do this properly. 3 times 2 is 6, times 2 more is 12. That fits our pattern. So I have 3g squared minus 2 times the quantity 3g squared minus 2, which again, when we simplify that, we write it as 3g minus 2, the entire quantity squared. Okay, let's look at the next one. All right, so I have 4t squared plus 36t plus 81. The square root of 4 is 2. The square root of t squared is t. Is 81 a perfect square? It sure is. The square root of 81 is 9. Now, if this follows the pattern, 2 times 9 is 18t times 2, which is 36t. So it definitely follows that pattern. So my final answer, 2t plus 9, the quantity squared. Let's try it again. Example D, is 25g squared a perfect square? Well, 25 is a perfect square. The square root of 25 is 5. The square root of g squared is g. We know that 9 is a perfect square. The square root of 9 is, the square root of 9 is 3. Let's check it. 5 times 3 is 15, times 2 is 30. So it follows our pattern. Notice that this is a subtraction sign. So my actual answer is 5g minus 3, the entire quantity squared. How could you check this? What did we do originally when we first started factoring and we wanted to check our answers? How could we do that? We could check it by FOIL, right? 5g minus 3 times 5g minus 3. If I were to FOIL, 5g times 5g is 25g squared. 5g times negative 3 is negative 15g. 3 times negative 5g is negative 15g. A negative 3 times a negative 3 is a positive 9. When I combine like terms, I end up with 25g squared minus 30g plus 9, which was, in fact, the original problem. So remember that you can always check by using FOIL. All right, let's look at this one. 5 is not a perfect square, and neither is 45. But I see that I have a GCF. Everything has a 5 and an x term. So I'm actually going to divide everything by 5x. Now, from grading your quizzes, sometimes we forget to write that down at the bottom. So I'm going to put it at the bottom of my paper. I want you to see that I've put it down there because I know that I'm going to have to end up multiplying that times my final factors. So when I take a 5x out of here, I'm left with x squared minus negative 30 divided by 5 is 6x. 45 divided by 5 is 9. Now I see that I have two perfect squares. The square root of x squared is x. The square root of 9 is 3. They are joined by a subtraction sign. So my final answer at the bottom, 5x times the quantity x minus 3, the quantity squared. So remember to watch for that GCF. I did go ahead and put one more in here. This is not in your notes, so I'm going to give you a second to write it down. Example F, 3x to the 6th power minus 12x to the 4th minus 75x squared plus 300. So first thing I hope you see is that everything is divisible by 3. So I have a greatest common factor of 3. I'm going to factor a 3 out. I'm going to put that right down here at the bottom. This one is kind of tricky. So when I do that, I have x to the 6th minus 4x to the 4th minus 25x squared plus 100. Now this has how many terms? Yeah, this has 4 terms in it. Remember, when we have 4 terms, we factor by grouping. looking for a GCF between the x to the 6th power and the negative 4x to the 4th. And I can see that I can take out an x to the 4th. That leaves me with x squared minus 4. Here, oh, my leading coefficient is negative, so I'm going to take out a negative 25. And that leaves me with an x squared minus 4. My repeated factor, x squared minus 4 times what I have left over, x to the 4th minus 25. Now I want you to look at this. Is this a difference of perfect squares? And this a difference of perfect squares? This is from lesson 8.8. When you have the difference of perfect squares, remember they can be factored by x plus 2 times x minus 2. And x to the 4th minus 25 becomes x squared minus 5 times x squared plus 5. So my final answer, I took out a 3, is 3 times the quantity x plus 2 times the quantity x minus 2 times the quantity x squared minus 5 times the quantity x squared plus 5. I gave you something like this because you might see something like this on your review. And you may see something like this on your test as a bonus. Okay. All right, so I want you to work on your lesson 8.9.